Okay, question number 1. We have e to power 2.3. So e is an irrational number that approximately is given, and or it's used in math widely. It's used for all kinds of economical problems mathematically. On 2.3, and e is approximately equal 2.718 281828. Okay, all right. So which means everything that is related to e will be calculated approximately. Okay, so how are you gonna find out how much is e to power 2.3? I will just tell you how to use this on the calculator that is in Windows 10. So Windows 10, you choose calculator has basic and scientific. You choose scientific calculator. You click the button E, okay, and then you have to choose button X to power Y, and instead of Y, so this automatically X will take as an E, and after that you click 2.3, and that will take your Y to 2.3 and will be E to power 2.3, and the result you should take would get it approximately should be 9.974. So one more time, on the calculator you click on button E. That's, I'm talking about scientific calculator that's coming with Microsoft Windows that the entire world is using. And then after that you push the X to power Y, because X automatically is given. Okay, and then you use your degree, which is 2.3, and you get 9.974 approximately. Okay, all right, so I'll clean this to get rid of mess, but the value of E we will keep. Question number 2. E to power negative 0.08. Now this is interesting, since we have, let me remind you about properties of exponent. If you have a to power negative x, it's automatically, when a is a whole number, that means it's, we understand it's 1, your denominator, right? So what does this negative sign at a negative degree? It flips the fraction, which means this a comes down with positive x and 1 comes up. That's all it flips. So for example, if you have, let's say, 3 to power negative x, so we understand denominator is 1, right? So then, since we have negative, to get rid of negative, we're gonna flip it. So will come, this one will come on the top, and 3 will go to the bottom with positive x. Now what if you have, let's say, e to power negative, okay, 0.08 over 4, right? then it's still gonna flip. You will get 4 over e to power 0.08, positive 1. But now, and lastly, what if you have a negative exponent at the bottom in denominator? Let's say you have 1 over 4 to power negative x. That's going to be equal 4 to power positive x, and 1 comes down, which is 4 to power x. And if instead of 1 you have something else, let's say 2 over 4 to power negative x, it's going to be 4 to power positive x over 2. That's all. Okay? I'm going to keep this because this is important properties of exponent, how to work with it. And in this case, we are going to have 1 over e to power positive 0.08. Let me see how much it will be, because you don't expect me to know this by heart, right? So clicking E button and then X to power Y button, and then degree 0.08. And I am getting, since asking round till 3 digits, so I'm getting 1 over 1.08 83. Okay, so which is going to be equal, I am dividing 1 by 1.083, and that is giving me 0.923. All right, we are good. Moving to next, and this is going to be approximately, when you have this wavy sign, that means it's approximately. Okay? Question number 3. We are moving to exponential function with the graph. Let me see, I have this. Okay, and so 1, 2, 3, 4, 5. So this is my 5, this is 1, because this is 2, this is 4. Here, this is 2, this is 4, and this one is 6. Okay, so one is going to be this point, and the other one is going to be point 0, 1, which is going to be this one. And the graph is going to go not bad. It could be a little bit more, but that's okay. So it's a function of format a to power x. A to power x. Now, how on the earth to identify which graph is this one? Very easy. Very easy. Look here. If my x would be equal 1, then a to power x would be a, right? Because I would get a to power 1 would be equal a. So if I have, let's say, my function is, for example, 3 to power x, yes? So when x is equal 1, right, I will get 3 to power 1, which is equal 3. From here, coordinate for x is equal 1, my y is going to be 3. If I have function 4 to power x, my x is equal 1. So it's going to be equal 4 to power 1, which is equal 4. So this is your value of y, just like here. So the coordinate is going to be 1 and 4. So to identify which function, exactly precise exponential function you see on the graph, What you're gonna do, you're gonna take your x is equal 1. So you take x is equal 1 and move up, see which number you're gonna hit. Whatever number you hit, it's gonna be that function. So we have 1 and 5, right? Which means our function is how much? 5 to power x. Because x is 1, y is gonna be 5. Very easy. Let's say I have, let me do drafting since I'm doing, so to make it easy to understand. Let's assume this is my 1 and, excuse me, this is my 2. And this is 1. Let's assume, so it's a sketch, rough sketch. So if I want to know what the graph of which function it is, I take this one, go up. If I see here 2, that means it's 2 to power x. All right? That's easy. And one more thing is crucially important. If the graph of the format a to power x, then there is no way that it won't cross in the point 0, 1. Why is that? Because when x is equal 0, doesn't matter what is the basis, right? It's a to power 0 gonna be equal 1. So for the case of 5 to power x, if x is equal 0, 5 to power x is equal 1. Because any number, let me write down here, a to power 0 is equal 1. There is no question about that, right? So a different story is why is it equal 1? If somebody is interested, just put it in the comment and I will go over, explain real quick. Now, let's say if I have 3 to power x, if my x is equal 0, it's equal 1. So it doesn't matter what kind of base you have, but what is important, as long as x is 0, it's going to be equal 1. So no matter what, it's going to cross through point, it's going to cross through the point 0 and 1. This is why any type of the exponential function, it's going to go through 1. Be it this one, going to go through 1. Be it this one, gonna go through 1. So doesn't matter. All exponential functions have to cross 0, 1. Okay? All right. So I'm going to clean this so we won't have a mess. And the answer for this equation, let me clean this also. So the graph is going to be like that. So this is going to be 5. Five and 1, and this is 0 and 1. Okay? Moving to next question. Okay, question. So, this one is 5 to power x, right? So we get y is equal 5 to power x. Let me draw as a draft here something else. I guess I will clean this one so I will have space for more drafting. If I have graph, I want to make sure we understand it well. So if I have this type of graph, so let's say this is, gee, looks horrible. So let's say here is 4, here is 1, and 4, 3, 2, 1. Okay. And my graph is going like this, and this is 4, this is 1, and I'm checking 0, 1, I have it also, and here is this is 1 and 4. Now what do you think, what the function does this graph represent? Of course it's going to be y to power 4 to y is equal 4 to power x, because when x is equal 1, y is equal 4. Okay, so hopefully this will make things clear. Okay, now I would like to show you one more thing. So we learned to draw 5 to power x, 4 to power x, meaning a to power x. Now what if I have, let's say, to draw 4 to power negative x? 4 to power negative x. Let me draw it right on this graph. So 4, it's here. So my graph is gonna go like this. Not bad, huh? Okay, so what does that mean? If I drop down, this is going to be negative 1, which means if this is my 4 to power x, okay, this is 4 to power negative x. How do I identify? Look at the point. When I take negative 1 and I go up, I get 4. So here this coordinate positive 1 and 4. This coordinate is negative 1 and 4. So if it's going from left to right, so you are taking negative 1, go up, and whatever number you get, that's going to be your base, like here. Okay? And if it's going from right to left, then you are taking positive 1, go up, and whatever number you get, it's going to be your base. Which means if I have 5 to power x, right, this is how it's going to look like. This is my 5. So for 5 to power negative x, I'm going to take, this is negative 1. So going up approximately here. So and my graph will go like this. And this point is going to be what? Negative 1 and 5. So which means this green one, it's going to be 5 to power negative x. While this brown one, let me a little bit make this more symmetric, which is supposed to go like this. So this one is going to be 5 to power positive x. Yes? All right. So in one also very important thing, no matter what, if it's negative x or positive x, both of them are crossing at the point 0, 1. Because if x is 0, it doesn't matter you have negative x or positive x, you will end up with 1. Let's see. 5 to power 0 is equal 1. And 5 to power negative 0, well, negative 0. There is no negative 0, right? Negative power as 0. It's going to be 1, 5 to power 0. It's going to be 1 over 5. I mean, to power, hold on, messed up. 1 over 1, because 5 to power is 1, and the result is 1. Okay? So that's how you identify. Okay. Question number 4. Let me get this one less. All right, it says graphing, we are going to graph 3 to power x. And using transformation of this graph, we need to graph g of x is equal 3 to power x minus 4. Okay, to make long story short, we need to graph g of x is equal 3 to power x minus 4. That's what we need to draw. Okay, so what do we have to do first thing? First thing we have to do is to draw 3 to power x, right? We have to draw 3 to power x. Okay, so let's do it. If this is 1, 1, 2, this is 3. So this is 1 point, this is 1. And here it's gonna be 1/3 somewhere. Okay. Let me go through this graph. So this is 3 to power x. Okay, so we have x to x minus 4. So we have to draw y of x is equal 3 to power x minus 4. Remember what I told you. This is when x is changing. This is a change of x, right? X minus 4. Then the shifting is going to go to the opposite direction. Since we have minus 4, guess which direction we're going to go? Positive 4, right? Which means this point that we have, that is 1 and 3, will become how much? 1 comma 3. This is my x. This is my y. So x is going to do plus 4, which means it will become 1 plus 4. It's going to be 5 and 3. Yes? So where is my 5? Let's go. 1, 2, 3, 4, 5. So if I move here, this is going to be my 5 and 3. Why? How it become 5? Because my x changed it by positive 4 and this 1 and then plus positive 4, I get 5. Okay, what's going to happen with this 0 and 1? 0 and 1 is going to become plus positive 4. It's going to be 4 and 1, yes? This is my 4 and this is coming, my 1 is going to come here. So my graph, it's going to look like I need thicker one. It's going to run parallel, but it's going to be shifted like this. Okay, and this graph is, let me paint in blue color. So g of x equal 3 to power x minus 4. Okay. We good? Now, so what did we do? We practically took and shifted this point 0.1, right? We shifted by 4 units to the right. Okay? Next, we need to draw the graph free to power. Oh, we draw already. We finished free to power x minus 4. Okay, now let's identify, do we have asymptote and what graph is our asymptote? Where is our asymptote is going to be, to what line the graph is running but never touches? This one. Yes? This is our horizontal asymptote, and this graph is our asymptote is, so it's practically horizontal asymptote, y is equal 0. Yes? That's the graph. So what is going to be domain here? Let's go analyze now. Number 1, this is horizontal asymptote. Equals 0. Now let's do domain. Remember what I told you in previous videos. If we don't have any break, right? If we don't have any break on the graph and graph goes smoothly everywhere, then our the domain is going to be what? From negative infinity to positive infinity. And indeed, if you look at the x, this is our negative x. This is our positive x, yes? Do we have x in the negative area? Yes, here it is. And green also come to negative area, right? Do we have positive area? Yes. So domain is running from negative infinity to positive infinity, and we to put in parentheses because infinity doesn't have limit. You cannot include in the square bracket. Now range is going to be different story. So it's running to, the graph is running to 0, yes, but it never touches to 0, which means my y, it's starting from 0, but not the 0 itself. That's why I put parentheses, so it's going to be greater than 0. And it's running all the way to where? Infinity, yes? All right. And running to infinity. And we are done. Question number 5. We need to build this time g of x is equal 3 to power x plus 3. Beautiful. Before we build x minus 4, now we are going to do the same graph x plus 3, which means this time graph is going to run where? To the right or to the left? Of course it's going to run to the left. So let's build it. Okay, so first I have to build what? 3 to power x, right? Okay, the graph 3 to power x, this is 1, this is 1, 2, 3, right? This is 1 point we have, and the other point is 0, 1, right? So my graph is going to go this 3 to power 1, it's going to go it's a 3 to power x. Now 3 to power plus 3, so it's going to go shift by 3, which means what's going to happen to our points, which means 1 and 3, it's going to become what? This one going to go by negative 3. 1 minus 3, it's going to be negative 2, right? Negative 2 and 3. And 0, 1, my x is 0. 0 minus 3, it's going to go negative 3 and positive 1, sorry. Negative 3, positive 1. Why negative 3? Because this is our value of x, and we do minus 3. Because here I have plus 3. So I have to do minus 3. Right? Okay. So this is our, let me highlight it into green color. This is our new coordinate, which is going to be, let me see, negative 2 and 3. So this is negative 2. And coming here 3, 1 point. And the other one is going to be negative 3. Here is negative 3 and positive 1. So 0, 1 become negative 3 and 1. Which means the graph is going to run like this and keep going parallel to your 1. Well, this one is going to go parallel. So this has to be more smooth, this corner. Smooth transfer. And this one, I would say it's going too far. So with the sense of angle, like this. Yeah, looks like parallel. Okay, good job. So this is 3 to power x plus 3. And we're done. So let's now look also at the asymptote. What is our asymptote here, horizontal asymptote? We have horizontal asymptote here, right? Y is equal 0, this one. And none of them is touching. Okay. Next, domain. Domain is going to be same way. It's the same graph, smooth, no breaks, no sharp corners. So it's going to be negative infinity, positive infinity. And the range also, it's going to be from 0 to positive infinity. It's going to go up from 0. But not including 0. That's why I put parentheses, because 0 is not included. Question number 6. Well, now we're going to have different fun. G of x, we have to build 3 to power x minus 2. Now, look at the difference. Now, what do we have here? In this case, we have a change of x, right? In this case, we have change of y. Because you take the entire function and shift down by 2. So, first of all, we have to draw 3 to power x. So this is 1, this is 3, point here, 3 to power x. So minus 2, we take entire graph and shift down by 2, right here. Which means, what we're going to have, the 0, 1 that we have, now the change of y, which means 1 minus 2, it's going to become 0. Now in this case, y is going to change. 1 minus 2, it's going to get negative 1. This is negative 1, negative 2, negative 3. And the point of 1 and 3, this one, this is 1 and 3, this is 0, 1, right? These 2 points, and 1 and 3 will become 1 stays. 3 minus 2 is 1. Remember, when we have change of y, it's changing straight forward. If it's minus, we go towards negative. If it's plus, we go towards positive. Okay? All right, so what do we have? 0.1 becomes 0.1, and 1.3 becomes 1 and 1 right here. It becomes 1 and 1. So let me see. The graph is going to go parallel. It's going to go absolutely parallel. And let me see. The our asymptote is going to be -2. So this is going to cross here. And it's going to come like that. So if you wonder why this is going to be, this is -2 asymptote, because look, we have here distance 1, right? So if this is my new point, so distance 1, it's going to be down by 1, -2. Okay? Or you can calculate this way. This point is 0, 0. So my 0, 0 is going to become 0, -2, right? Because we are doing -2. That also will work. And this is our graph. So what we do, we take the graph and shift by 2 units downwards. All right? Okay. Now, what else we have? How much is going to be my asymptote? Tell me, please. It's going to be 0, y is equal 0? No. It's going to be y is equal -2, because here it is, it's running -2, running towards -2, but never crosses. Okay? How about domain? No problem whatsoever, same thing, -infinity, +infinity. Now, regarding range, it's a different story. Before it would start from 0, now it will start from, that's right, -2. And all the way to +infinity. Question number 7. I hope you are learning, getting a good feeling of it. It's not difficult as it looks like and sounds like usually. Students are running away from this type of questions. Next one. So, okay, we have g of x, and this time we're going to do 3 to power x plus 1. Let's move now up. Plus 1. So again, this is a change of y, right? Change of y. And let's see, the graph is going to look like. This is 1. This is 1. This is my 3. It's going to go like this. Okay. This is 1, this is 3, and this is 0, 1. All right? So we need to add plus 1. So we have to take it, the graph, and shift up. So to be precise, the point 1 and 3, it's going to become what? Plus 1, it's going to be 1 and 4. Yes? And the point 0, 1, it's going to become 0 and 2. So I'm doing plus 1 for every single y. And which means this our y is equal 0, the asymptote, it's gonna become, oh, I have it green, let me make it blue. Okay, so it's gonna become 0, 0, it's gonna become, take a guess. Actually, you don't need to guess, so just take 1 and add to this 0, because that's our y, and you have it. So our points, 1 and 4, right here. And then we have 0 and 2 right here. And 0 and 1, this is our vertical asymptote, the horizontal asymptote, which the graph is going to go like this. So this the green color graph, it's going to go very close, parallel, and come to this asymptote. It gets close but doesn't cross. So if this is 3 to power x, this one is 3 to power x plus 1. If we compare to graph, what do we see? We see this point is 1. This point is 2. So practically we take entire graph and shift it up by 1, because this is 1 difference. Okay? All right. So from here, our horizontal asymptote is going to be y is equal 1, right? Domain, no question, negative infinity, positive infinity. Range is going to come from when? From 1. From 1 to infinity, because this is a change of y. Question number 8. Now, this one I'm going to do full combination of shifting right, shifting horizontally and shifting vertically. Let's do it. And we're going to build right away, and I will show you how to do it without drawing this 3 to power x. Now, we have question number 8. We have h of x is equal, well, it's given again through 3 to power x, but if you want, we can take 4 to power x, doesn't matter. Okay, let's take 4 to power x plus 2 and minus 1. I'm going to show you a very easy way. So first of all, let's identify two things. This is our change of x. Okay, you know, I don't like messing with original one. Let me write here. So plus 2, this is our change of x, right? Change of x. And it changes by negative 2, because it goes by opposite direction, correct? This one is, take lighter color. This one, minus 1, is our change of y. And it changed by negative 1. I don't like this in parentheses. It sounds like, looks like a coefficient. So let me make a space and put like that. Minus 2. Okay. Minus 2, minus 1. Okay. So now we can build it. If we have graph 4 to power x, that means if it's 4 to power x, this is 1, this is 1, 2, 3, 4, right? This is 0, 1. So this is going to be our 4 to power x. I'll use white color so it won't clean everything. So this is our 4 to power x, right? Now, points we have 1 and 4. Points we have 0 and 1, right? And point we have 0, 0. So 1 and 4, what's going to be? This is my x, this is my y. X is going to change by -2, which means 1 minus 2, it's going to be -1. And y is changing by -1, so 4 minus 1, it's going to be 3. Next, 0, 1. 0 minus 2, it's going to be -1. No, it's 0, so -2. And 1 minus 1, it's going to be 0. All right? And 0, 0, which is going to be replaced with -2 and -1. So, my new coordinates are going to move. The 0, 0, this line is going to become -2. This is 1 and 2. And -1. So moving right here. -2 and -1. This is going to become my new x and y. Next, -1 and 3. This is going to be -1. My x is -1, and it's going to be positive. Yeah, I was taking on that. -1 and going positive 3. It come right here. -1, positive 3. And then I have -2 and 0. This is where it's going to cross. And it's going to come to -2, -1. This is this one, -2, -1 point right here. Which means the graph is going to come like it's going to come like this. Now if I make it this look solid also, all right. Okay. So this is our 4 to power x. And this one is my 4 to power x plus 2 minus 1. Let's see. Let's check it. My x has to be shifted by -2, right? Well, we'll see. Here is 0. Did I move by -2? This is -2. 1 and 2, right? Moved x by -2. My y has to be shifted down to -1. So this is, I have 1. So it's shifted down to -1 right here. Entire graph is shifted by -1. It was 0, 1. It became -2 and 0. And this is your graph. Let's figure out our domain and range. So we shifted graph 2 units to the left and 1 unit down. So what's this asymptote? Our horizontal asymptote is y is equal -1. Why? Because it's shifted down by 1, right? This is -1. Domain is going to be again -infinity, positive infinity. How much is going to be at the range? It's going to start from -1, yes? So range is going to be -1 and positive infinity. All right, moving to question number 9. Question number 9. So let's do another question similar to 8. So make sure we are doing good. H of x is equal 3 to power x plus 1 and plus 2. We are dealing with plus everywhere here. All right, so let me see. This is, one more time. So this is our x and y. So 3 to power x, meaning this is 3, this is 1. Here is 1, 0, right? And the graph is going to go like this. So this is 3 to power x. Now let's see. This point is 1 and 3. Let me see if I can move this down a little bit. Okay. Point 1 and 3. Point 0 and 1. And 0 and 0, because this is also going to shift down, correct? Let me see if I can clean this one. Okay, got it. So, which means it's gonna go like this. This is 1, and this one is coming like that. So this is 0, 1, and this point is 0, 0. So 0, 1, 0, 0. Let's see where we are heading with this. So x is changing by -1, right? X is changing -1. Y is changing +2 everywhere. So that's going to be 1 minus 1, it's going to be 0. 3 plus 2, it's going to be 5. Next, 0 minus 1, it's going to be -1. 1 plus 2 is equal 3. 0 minus 1 is -1, and 0 plus 2 is +2. So from here, we are getting the our graph 3 to power x plus 1 and plus 2. It's gonna be my 1 and 3 point. It's gonna move to 0 and 5. This is 3, 4, 1, 2, this is 3, this is 4, this is 5. Okay, this is 5. 0, 5, the 1 point, and then I have -1 and 3. This is 3, this is -1. So -1 and 3, to write this point. And I have -1 and 2. 1 and 2, it's coming. Let me see. 1 plus 2, -1 and 3. And then -1 and 2. Okay, -1 and 2 is this one. So this is y horizontal asymptote is coming right here. plus 2, and it's going to be negative 1. It's right here. So my y is shifting here, and x is shifting right here. So we are getting new intercepts. Okay, so these 2 points we have mainly this one, and it's going to run to where y is equal to, let's see, well, approximately it's parallel. So this one is our 0 and 5. This point is our negative 1 and 3. And this is our horizontal asymptote. Okay? So, what do we have from here? We can say that we took this blue exponential function, shifted up by 2, right? 1 and 2. Yes. Oh, this one. 1 and 2, like here. Let me see. I wanted to clean this. There we go. So it was 0 here. 0, 0. We get here, we moved it here, up by 2, right? We got 0 and 2. Oh, negative 1 and 2, okay, I'm sorry, here is mess. This 0 is from previous case. I'll tell you what, I'm going to make it much better. I'm not going to draw on the same graph. 1 second, it will give me 1 second, I will make it clear so we can understand better. So here we have this is 1, this is 3, 1, 2, 3, this is 1, and it's gonna go like this. So 1 and 3, and here is 0, 1. Now I'm going to build here separate. Let me go with this. Okay, and another one. All right, so 1 point, this our points, 1.3 becoming what? 0.5, 1, 2, 3, 4, 5, right here, 0.5, and where the 0.1 become negative 1 and 3, negative 1, and coming up 3, right here. And 0, 0 become negative 1 and 2. This is going to be my 0, 0. This is negative 1 and 2. This is going to be my new x and y. Okay? This is negative, this is positive 2, this is negative 1. So the graph is going to go like this. So what did we do? So our graph, this blue one, we shift it up by 2. Here it is. We shift it up by 2. Right? This is positive 2. And then shift it to the left by 1. Here it is. This is negative 1. So here we have up to the left by 1 and up by 2. And that's exactly what we did. So this is our y is equal 3 to power x plus 1 plus 2. Okay, instead of y, let me put h of x because that's what they have. So we have it matching up. Here is our graph. Okay, so what do we have here? We have our asymptote, horizontal asymptote is equal, y is equal to, this is where it is, and then domain is going to be the same, negative infinity, positive infinity, and the range is going to start from where? From 2, right? But 2 is not included because it's an asymptote. It never touches 2. Okay, so I will build separate now from now on. So it would be easy and can see, otherwise it gets crowded like this. Okay, question number 10. Okay, we are getting to new format. Question number 10, we are getting into new format. What format is that? G of x is equal negative 4 to power x. It's going to be equal negative 4 to power x. Okay, let's do it. This is 1. This is 2. If we would have positive 4 to power x, we know it would be 1, 2, 3, 4. This is 1 point, 1 point, and the graph would come like this. Right? 1 and 4. But we have negative 4 to power x. So what is going to change here? Instead of positive 4, we are going to get negative 4, which means for this case, we are going to have positive 1, but negative 4. 1, 2, 3, 4. So it's going to be negative 4. It's going to be 1, positive 1, but negative 4. Why? Because if my x is 1, then negative 4 to power 1 is going to be negative 4. That's why we're getting negative 4. Okay? And it's going to go through 0, negative 1. Right? Because when you have negative 4 to power 0, you are getting negative times 4 to power 0. That's what it means. And that is equal negative 1. Therefore, we have here negative 1. So, which means it's going to reflect about the x-axis. So, let me see if I can. Wish me good luck. So, there we go. So this is negative 4 to power x. Yes, you can see it's like a mirror. They are splitting and reflecting. You take this 4 to power x graph. Oh. You take this 4 to power x graph and flip it down. And you get this way negative 4 to power x. All right? So this is the graph. We reflect about the y-axis, x-axis. We reflect about this axis. Okay. Let's see. What is our asymptote here? Asymptote is still going to be y is equal 0, right? What is going to be our domain? It's still going to be negative infinity, positive infinity. And what is going to be range? This is interesting. It will start from negative infinity and grow here all the way to 0, because this line is 0, right? It's running to 0, but never crosses. That's 4. We put in parentheses. So it's going to be from negative infinity to 0 in parentheses. All right? Question number 11. I guess now we are going to manipulate with this. So now h to power negative x. We already built 8 to power negative x, but that's a good thing that it came across, so you can see negative 4 to power x and 4 to power negative x. So it's 8, but doesn't matter. G of x, 8 to power negative x, which means this is 1. This is 2, so we are going to go 8, right? So this is going to be negative 1 instead of positive 1, and go by 8. 1, 2, 3, 4, 5, 6, 7, 8. All right? This is our 8. See, the higher of this base, the closer to y it comes. 8, and here it's coming from to negative 1. So it's going to come like this. 8 to power negative x. Well, everything else we know. It's horizontal asymptote is y is equal 0. Here it is. And then domain is going to be negative infinity, positive infinity. Range is going to be from 0 to positive infinity because it's going up and starting from 0. Question number 12. All right, now we're going to build the graph using E value, our Euler number. We call it Euler number. That's why it's E. It was created by Euler. This E is widely used into algorithms, logarithm, natural logarithm. That's coming next video. Okay. Question number 12. We need to use e to power x plus 3. G of x is equal e to power x plus 3. Let me drop this down. We will manipulate a little bit with x. Since e is equal approximately, we use 2.771 or 72 if I round it up. Let me see. I think 7.2, yeah, because here is 1 and then 8, so 2.72 precisely, if I round it, 2.72. So which means it's going to be between 2 and 3, but close to 3, yeah? Let's build this. This graph. I don't know why I didn't move it down. Much better. Moving down. So, let's see, e to power x. So if it would be 3 to power x, I would go 1, 2, 3, right? 1, 2, 3, and 1. But I have 2 to power 2.72, which is going to be somewhere here. If this is 3, this is 2, 272, it's going to go somewhere between. Also, e to power x, it's still going to be 0 and 1. So this graph is going to be e to power x. This coordinate is 1 and 2.72. This one we already know, it's 0.1. Now we have x plus 3, which means we are going to shift by negative 3. Yes? Which means coordinate 1 and 2.72. It's going to shift it to, since I have 1 minus 3, it's going to be negative 2 and 2.72. Okay, let me move this, I guess. Okay, this way. And then 0, 1, second point, we are interested. It's going to shift by 0 minus 3. It's going to be negative 3 and 1. And this 0, 0, we want to know where it's moving this asymptote, right? 0, 0. 0 minus 3 is going to be negative 3 and 0. So, will it be too much mess if I draw on the same place? So, let me see. Negative 2. I'll try. If not, then I'll go negative 2 and 2.72. Here is 2.72. This is negative 2. This point. So this is negative 2 and 2.72. Negative 3 and 1. Here is negative 3. This is 1. The coordinate is negative 3 and 1. And negative 3 and 0. Negative 3 and 0. It's going to be like that. All right. So, let's see how it's going to go, my graph. It's going to come from here. And come there, while this one also coming here. Not bad. This curving part is not precisely, but that's okay. Use your imagination. It's supposed to be parallel because here we have e to power x plus 3. E to power x plus 3. Okay? Okay, negative 3 and 1, that's where it's crossing. This point is becoming this point. Okay. Actually, let me see. That would be the right thing to do. Clean this one. And I move to here so you can see where it's crossing precisely, right here. Crossing that 0.1 here is becoming negative 3.1. Yeah. Okay. There we go. So again, what's going to be here? Horizontal asymptote. It's y is equal 0. Domain. Same old, same old. And range is going to be from 0 to infinity. Question number 13. Now I guess we are going to manipulate with e. Now we have e to power x minus 4. We drew the function with plus 3. Now we will do with minus 4. Number 13. So e to power x minus 4. Let's do it right away without drawing e to power x. So we have same points. Same points we have. So I'm going to shift by plus 4. X is plus 4. Let me write down. I have points 1 and 2.72. I have 0 and 1. And I have 0 and 0. So what we are going to get here? Since we have, we move it down, it's too crowded. Okay, we are going to do plus 4. Since it's minus 4, we are going to do plus 4. So, and it's going to be change of change of x, right? So here we get 1 plus 4, it's going to be 5 and 2.72. 0 plus 4, it's going to be 4 and 1. And 0 plus 4, it's going to be 4 and 0. Okay, and I'm going to build the graph, and I'm not building e to power x anymore because we already know how it looks like. So shifting points, we go by points. This one, and then this one. All right. So let's build the points. One, two, three, four, five. Oh, 1, 2, 3, 4, 5. So this is 5, and this is 2.72. So 5 and 2.72. This is 3, this is 2, this is 5. And then positive 4, positive 1. Comes here. This is going to be our new y-axis, actually, because this point is moving here. And then 0, 0, it's going to become 4 and 0. Positive 4 and 0, it's right here. We have already 4 and 0. So the graph is going to go like this. So this is e to power x minus 4. And we can see that we shifted by, oops, oh my gosh, disaster, sorry. I didn't mean to scare you. Okay, so we shifted by positive 4. We took the graph that was supposed to go like this, and we shifted by positive 4. Okay? Well, Sounds like broken song. So y is equal 0, domain negative infinity, positive infinity, and range is from 0 to infinity. Question number 14. We are going to build g of x is equal e to power x minus 2. E to power x minus 2. So now we're shifting down by 2. All right? This one. And this one. Again, using same points, 1 and 2.72, and then 0 and 1, and then 0 and 0. So we are changing now y by negative 2. So it's going to be 1. So 2.72 minus 2, it's going to be 0.72. It's going to be 0. 1 minus negative 2, it's going to be negative 1. And this one is going to be 0 and negative 2. So right away, I'm building this negative 2. So this is x-intercept moving to by negative 2. This is going to be our new asymptote. Our 0, 1 becoming 0, negative 1. And 1 and 0, 72 right here. This is 1. And this is our 1. So this is going to be 0, 72. Okay. So the graph is going to look like all right. So wherever this 0, 0 will move, that's going to be your asymptote. So in this case, let me write down, this is g of x is equal e to power x minus 2. Indeed, see, if my original one would go like this, so we shifted by 2 down, right? This is 1, this is negative 1, by 2 points down. All right? 2 units down. The rest is the same. What is my horizontal asymptote? I just mentioned it, right? Negative 2. Wherever you shift this 0, 0, that will become your new asymptote. And then domain, negative infinity, positive infinity. I will sing this domain after a while. And range is obviously from negative 2 to infinity. And negative 2, we don't put in square bracket because 2 is not included. It's greater than. Yes? Okay. Question number 15. E to power x plus 6. E to power x plus 6. All right. Let's see. Moving again, same points. 1, comma, 2.72. Now we are doing shifting by y up. And then we have 0 and 1. And we have 0 and 0. So we are going to get y, we are going to plus 6. It's going to be 1 and 8.76. So we're going to do plus 6 throughout every single y. So it's going to be 0 and 7. and it's going to be 0 and 6. What is going to be this 6 that we have? Your new asymptote. Here is the graph. So let me see, I have to get to 8 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not bad. There we go. And this is my y, my x. This is 1. So 8 and 9, it's going to be here. This is 9. This is 8, so 1 is going to be somewhere here. 0 and 7, it's going to be right here. And 0 and 6, it's going to be our new asymptote. 7, and this is going to be our 6. This one is 7, and this one is 1 and 8.76. And this is going to be our graph. Like this. So we practically, if I would build e to power x, let's say 1, 2, 3, it would be somewhere here. And it would go through this and 1.0. This would be my e to power x. So I would take and shift by 6. Okay, this point moved here by 6. This point moved here by 6. The entire graph I took and moved up by 6. Okay, so horizontal asymptote. It's y is equal 0, domain, negative infinity, positive infinity, range is gonna be from when? From 6, here, 6 to infinity, and this is 6. Question number 16, I have 4 more questions to cover, and it's gonna be same E, but it's gonna be everything shifting horizontally, shifting vertically. It's going to be fun. 16. So we have e to power, let's say h of x is equal e to power x plus 1 and minus 1. All right, so let's mark down. X is going to change by negative 1. Y is going to change by negative 1. So we have plus 1, negative 1. Let me write down these coordinates that we got. Or I can write down, let's do it so you won't forget where from we got these points. 0 and 1 point. I'm building e to power x. So if this is 1, 2, 3, this is 2.76, and here is 1, right? So this is my e to power x. So this point is 1 and 2.72. I don't know why I put 6. 72. And then 0 and 1. And 0 and 0. So 1 and 2.72. What do we have here? We are going to change. X is going to be changed by a minus 1, entire x. And then y is going to be changed by minus 1 as well. So let's see, what do we get? One minus 1, it's going to be 0. 272 minus 1 is going to be 1.72. 0 minus 1, it's going to be negative 1. 1 minus 1, it's going to be 0. 0, it's going to be negative 1 and negative 1. So this is going to be our asymptote. Okay, my graph, 0.172. I guess I'm building the new one because it's going to be messy there. So 1, 2, it's going to be 0 and 1.72. This one is 0 and 1.72. This is this one. And then I'm going to have negative 1 and 0. It's going to be this one. Negative 1 and 0. This is going to be this one. And negative 1, this is going to be negative 1, this is going to be my new asymptote, right? Okay. So, how is gonna go my graph? There we go. All right. This is how it's gonna go. So you wouldn't wonder, so since this negative 1 came down here, so you wouldn't wonder what happened to this negative 1. This is gonna be our new y-axis. This y-axis that we had, it's gonna become right here, new y-axis. Okay? And that's why it's gonna move here, this point. This is this point here, becoming this point here. Let me use this one. Okay, so what did we do? We shifted by negative 1. Here it is. Shifted by negative 1 to the left. And shifted by negative 1 down. All right. So, horizontal asymptote. Why this vertical line, if you ask why this vertical line is not considered as a asymptote, vertical asymptote, because it's crossing. Simple as that. While y is equal negative 1, it's not crossing, see? It's running to it, but it's not crossing. All right? So, domain, quickly putting there, I'm not even discussing this, and range is obviously negative 1 and infinity, because this is our negative 1. Question number 17. Okay, it's very similar one. I guess I'm going to skip. It's enough. It's gonna be the same. So I'll put here question number 17. See question number 16. So it's enough. And then, okay, now 18, it's gonna be different story. E to power negative x, e to power negative x. Remember when we have exponent negative, how it's gonna go? So 2 point, it's gonna be -1, and 1, 2, 3, 2.72, it's coming here. And 0, 1, it's here. And the graph is going like this. Let me make it thicker. Okay, so this is 2.72. So -1, so this point is 1 and -1 and 2.72. And this is 0 and 1. Okay, so, and this graph is e to power negative x. So it reflects about y-axis, right? Because e to power x would go like this. Something like. Okay, I am done. So I hope this video will help you to understand exponential function and transformation, right and left, up and down. And I see you at the next video. Thank you for watching.